We believe that future infrastructure should be schema-driven, cloud-native, and open. That's why we created a use case in our bachelor thesis connecting Infrahub, a schema-driven inventory system, with Kubernetes. So why would you want GitOps? Today there are workflows out there which are really awesome already with Git and Argo CD or Flux, which make sure that the definition in Git is continuously delivered to Kubernetes. But in a normal use case like that, someone would create YAML files in a Git repository, which then create the Kubernetes resources. And afterwards, you would go in and add to your inventory system what your infrastructure looks like at the moment. And wouldn't it be awesome if you change it around? Like you go into the inventory system and just put in what you need, and from there the automation takes place and the Kubernetes resources are created. We used the schema-driven Infrahub to model Kubernetes resources and to act as our single source of truth. The vision of this project was really to rethink the way we manage and deploy Kubernetes resources in a way that we can model any kind of resource within Infrahub, since it's model-driven, and have a nice UI for the administrator, but also for users which are non-experienced with Kubernetes. The workflow we imagine is that a user which is non-experienced fills out a form and creates a proposed change. The administrator then can decide if that change is valid and merge it into the branch, which is continuously monitored by our operator, Vidra. Vidra was designed to be lightweight, efficient, and a reliable Kubernetes operator that seamlessly integrates with Infrahub, allowing you to deploy the current state, the source from the source of truth, or even roll back to older versions within Infrahub. We have built Vidra as modular and extensible as possible, allowing for easy addition or change of the system which you decide to be the source of truth. And that's also why we decided to open source it, so that it can be used and extended by the community. We believe that by sharing our work, we can help others create a better cloud-native workflow for their environment. So, how did we achieve that? Let's look at our architecture. First of all, we have Infrahub with all the automation, which generates Kubernetes manifests out of the information which is added to it. And as I said before, we wanted to make it as easy as possible for users. That's why we created also a little front end which creates a proposed change. So it creates a new branch within Infrahub with the information, and the administrator can go in there and say, yes, that's valid, I want to merge it and deploy it to my cluster. Now for that to work, we have Vidra, the Kubernetes operator, which consists of two separate controllers. The first controller is managing the download and syncing with Infrahub, And the second controller is managing all the deployments and making sure that the state in Kubernetes is always the same as the manifest which he gets from the Infrahub sync controller. Now, this separation with the two controllers would allow us to create a new controller for any other system out there to act as source of truth. We also chosen to create a little CLI tool which creates all the needed secrets and configuration maps for Vidra and makes it easy to use. Now, to wrap it up, you can find all the information within our documentation, and there is also the whole code source online, of course, and we even provided a demo repository where you can spin up all the needed resources, so Kubernetes cluster, Vidra, and all the bits and parts within code spaces.